Hello everyone. Today I'd like to talk about why I decided to purchase an Arco Zeus regulator for an alternator on my sailboat. The sailboat is currently being upgraded to 315 amp hours of lithium batteries, and as everyone understands that if you take a stock alternator, which happens to be a Mitsubishi 50 amp alternator, charging the lithiums will destroy the alternator. I did not want the complexity of using a separate AGM starter battery and a DC to DC converter like most folks do. That's just more complexity and more weight. This Zeus product can protect my stock alternator in 3 ways. It will measure the current coming from the alternator to the batteries. It will measure the alternator duty, which is here, which is how much current is actually going to the rotor inside the alternator, which is usually called the field coil. This voltage here is measuring how much voltage is going into the field coil, and this light bulb is simulating a load of the field coil of the alternator. For those that don't know, that's how you adjust your alternator output, and it is actually listed here as alternator duty. So right now what we have going on is we're simulating that this is hooked up to an alternator. I have a power supply here simulating a battery. Up here I have a function generator and a scope monitoring the waveform that is simulating an engine being connected. That's where this RPM says 1850. I have this power supply simulating an actual voltage output from an alternator, and also we have an alternator temperature sensor which is sitting here. So there's several ways that this device can protect the alternator. It can protect it by limiting the amount of battery amps. This is a fantastic user-friendly app that will let you tailor this regulator to your boat and your alternator. So right now it's charging at 1.4 amps. Engine RPM is 1850 RPM. The alternator duty is 58%. Alternator temperature is 75 degrees. And obviously for lithium it's charging at 14.4 volts. Now if I increase the load, this is a load bank down here, we're going to see the alternator duty start to climb up, because it's going to notice that the voltage is coming down as I load, simulating a load, charging a battery, or things you turn on in your boat. So now we see the alternator duty increasing. We can see the battery charging amps is up to 2.5 amps, and we can also see that my load light bulb is starting to increase, and we also can see the voltage here is now up to 10.6 volts and climbing as the alternator duty climbs. That's another thing I want to speak about also. This alternator duty is programmable. Now I have set mine, and I will tailor these settings as this is installed on the boat. I have it set so that the alternator can never charge more than 90%. So this is going to come up to 90% and it's going to stop, and it's not going to go any further. And it's listed here, flow charging RPM pullback. So right now that won't charge more than 90, so that's going to help prevent an overload on the alternator. The second thing that it can do is if I start loading the alternator down too much, right now I have my maximum battery amps. Again, this is a test bench setup. You'll have a much higher amperage set for a real alternator. I have it set to 5 amps. So right now the alternator duty is 90%. It's 12.6 volts. As soon as I start loading this down over 5 amps, you're going to see this alternator duty start to drop down. You would use this in a situation, what I plan on doing is it's a 50 amp alternator, and I'm going to tell this not to charge over 40 amps. So that's going to help protect the alternator, because you can't keep it charging at 50 amps continuous duty. So now we see the alternator duty is starting to drop down because I've went over the 5 amps that this was set at. And now you can see the voltage coming down here that would be going to the rotor, and you can see this light bulb starting to get dim with the fake load. So now if we reduce the load, the amount of amps the alternator is putting out, simulating that the batteries are starting to get charged, we're now going to see this alternator duty start to come back up because we're not overloading the alternator. See, as the battery amps decreases, the alternator duty is starting to come back up. Our voltage is also starting to come back to the rotor because that's what this alternator duty is doing. It's putting more current into the alternator so it can put out more power. We can see our battery voltage now is coming up to 14.3. It's basically a closed loop system. It's looking at the current, and if that current exceeds whatever you set in the app, it's going to start reducing the alternator output. Now we'll talk a little bit about the engine RPM. A lot of engines don't like a fully loaded alternator at idle. It makes them stumble, it drops your idle down. So this actually has a chart. Let's see if I can bring this up. This is a chart which you can tell how much you want the alternator to charge and at what specific RPMs. So I have mine set that if the engine is above idle, let's say 1800 RPM, I can get 90% output out of my alternator. Now if I lower the engine RPM, I want the alternator to charge less, so it's not lugging it down when it's at idle. So we're going to simulate changing the engine RPM, that coming over here and faking it out and telling it that it's a lower RPM with this function generator. I'm going to have to go down a little bit lower. So now I have the RPM of the engine at 1300. Notice that now it's only charging at 50%. As soon as I increase the engine RPM, the simulated engine RPM, look how the alternator duty went right back up to 90%. This is so I'm not overloading the alternator at a low speed. And by the way, that's what helps to burn out alternators. If the alternator is not spinning, the fan inside doesn't get to cool the alternator off, and that'll make it overheat badly. So you definitely want to have your alternator not trying to put out a lot of current at a low RPM. Now see here it's 1650, it's down to 77%. Keep dropping this more. So at 1450 it's down to 60%. At 1300, 50%. If the RPM drops even lower than that, let's say now my engine idle is about 1300. So if for some reason motor was really overloaded and it got down to 1150 RPM, the alternator duty's down to 34%, which equals about 4.8 volts on the rotor. As soon as we bring the RPM of the engine back up, you can see that it's up to 47, 50. That as the engine RPM comes up, the output of the alternator is going to come back up. And again, it's totally programmable. You can set it to whatever you want. That's why I really love this device, because it allows me to do what I want it to do, not set with dip switches like most manufacturers' regulators are. I can make it do exactly what I want it to do. Now, here's another thing we can do to protect your alternator. This here's alternator temperature. So we're charging at 90%. Like I said, I have mine set to never charge more than 90% to try to protect it from ever getting hot to begin with. And this is totally programmable. You can put it 100% if you want, it's fine. So I'm going to take a heat gun here, and I'm going to simulate the alternator getting hot. So here we can see the alternator temperature coming up from the heat gun. 84, 86. When this gets, I have mine set to about 190 degrees. So when this gets to close to 190 degrees, it's going to start cutting the alternator duty back, which again is lowering the output current of the alternator by lowering the field voltage. You can see right here our field voltage is 12.8 right now. So we're 140, everything's still hunky-dory. 150, 158, 160, 160, we're still charging at 90%. 170, 180, 185, and here we go. At 190, look how immediately that alternator duty went down to 1%. So basically that's making the alternator stop charging. See, now our voltage here for the rotor is down to 0.13 volts. As soon as the alternator cools down, here we go, 187, the alternator duty is now coming right back up. And it'll go right back up to 90% again. And all of this is adjustable. You can go into this app and adjust whatever temperature you want, how much current output you want the alternator to put out. This is a totally amazing device that allows you to protect your alternator in many ways. And currently there was no other regulator that can do all of these functions and have the programmability that the app allows you to do. So again, this will allow me to take my stock alternator, which I'm going to modify and disable the internal regulator, and all I have to do is bring a wire out and connect it to the field coil on the Zeus regulator. So now see, 190 degrees, it's starting to cool down, and now our alternator duty is coming back up. Most of the other devices on the market, like the Balmor, they strictly work by temperature. They don't look at the alternator current or the alternator duty at all. As soon as it gets hot, it starts cutting back the alternator. And there's not that much programmability. Here you can go in this app and do anything that you want. It's totally amazing how much work they put into this app. You come into here, you set your battery amp hours. See, my maximum charge current's 5 amps. That's not a realistic figure, we're just using that for test. You can set it to whatever the alternator can take and whatever current you want it to put out, so you're not burning it out. And there's settings in here for the alternator, the type. You can set maximum operating temperature. Again, we discussed the RPM. Charge profile. This is where you would set your absorption voltage. All kinds of settings. This will also work with AGM and lead acid too, by the way. Then you come into the regulator, and there's all settings for that. This also has NEMA 2000. I may eventually tie that in so my Garmin GPS can get this information. Tachometer information is load configuration. There is so much adjustability, and the app is so easy to use. It works with Bluetooth. You don't have to drag a computer around to the boat and plug a cable in it. Everything's done wirelessly. So for those that want to use their stock alternator or a higher current alternator like a Balmor or any other brand, This is a great feature. And like I said before, this will be fantastic. No DC to DC converter. The problem I have with that is most of them are 30 amps. So now if you have a 50 amp alternator, you're limited 30 amps. So then, okay, well, I'll parallel two DC to DC converters. So now you got the complexity of two DC to DC converters to handle the 50 amps, which, you know, would be 60 amps because they're 30 amps, most of them. This is simple. Just add this simple box to your alternator. Gets rid of having an AGM battery or a lead acid start battery, because most lithium batteries, they can now start the engines, especially if you have three of them in parallel like I'm going to have. It's going to be no load for the batteries at all. It's just less complexity, less to go wrong, less weight. And I hope someone finds this video useful, because I think this is a fantastic addition that we can use for our boats and RVs. Take care. Have a wonderful day.